Welcome to the SciShow. Let's get started, shall we? The world of Universal Century from the popular Japanese animation Mobile Suit Gundam Unicorn is a world of possibilities. It is a world where the power and promise of technology grants humanity much prosperity in a new age of space exploration. This technology can also become a curse, resulting in warfare and the ruin of much of that potential. But how much of that world from Universal Century is starting to show up today? Although we still live in the common era of Anno Domini, and according to the writers of Gundam, Universal Century is still set to take place decades away from today, there are elements of the Universal Century that are starting to appear in our modern era, spanning different fields of science from astrophysics to neuroscience. So all my new types and old types out there, coordinators and innovators alike, ladies and gentlemen, I present to you today the top 5 technologies of Universal Century. As seen today. Number 5. Beam and energy projection. Much like other science fiction universes, beam weapon technology like beam rifles and lightsabers make an appearance in the Gundam universe, changing the way humanity fights its battles. High-powered beam weapons can make short work of very thick armor, ushering in a new age of warfare. Directed energy weapons, like the name implies, uses energy projected over a certain area of effect to either disorient or completely destroy targets. And although we don't specifically have beam rifles today, we do have something called lasers. Laser stands for light amplification by stimulated emission of radiation. You learned in grade school that everything is made out of atoms, and one characteristic of atoms is that when they are stimulated by light, they emit photons or particles of light. Different atoms have different emission characteristics, and what a laser does is that it concentrates these emissions onto a very narrow beam with very high intensity. Now, the invention of the laser was something that stemmed out of Einstein's photoelectric effect, of which, during the time of its discovery, was not evident would lead to the invention of the laser. In science fiction, directed energy weapons are usually bad news. They're typically a cause for more destruction than good. But today, the laser has found use in many different everyday applications, from laser cutting to range finding and surveying and even eye surgery. Modern use of lasers can actually help save human lives, and perhaps on an even higher level, help us solve our emerging energy needs. No way! Yes way! Welcome to the National Ignition Facility, or NIF Fusion Reactor, based in Mount Livermore, the good old US of A, where we're aiming the world's most powerful lasers at a single spot in an attempt to unlock the energy hidden within the atom. These powerful lasers are designed to crush hydrogen nuclei together under such high intensity to produce a nuclear fusion reaction. You may recognize it as the engine room from the Starship Enterprise from the movie Star Trek Into Darkness. Through the use of these powerful lasers, one day, we will be able to harness the power of a star here on planet Earth, generating a clean source of energy with near zero pollutants or greenhouse gases. Number 4. Spaceflight technology. Spaceflight is more prominent in the Universal Century, with space vehicles being able to transition in between space flight back to atmospheric flight through a transformable re-entry mode. In the world of Universal Century, space flight is routine and space travel is just about as ordinary as driving your car to work. However, commanding a space vehicle is something that takes some really serious spacer balls, like those found in Londo Bell Commander Bright Noah. Aha, he said balls. Yes, I said balls. Today, scientists, engineers, and even futurists have proposed different forms of spaceship designs with different propulsion mechanisms ranging from nuclear power to solar sails and even ion engines. But what hasn't changed is how we get to space. Short of building our own stairway to heaven. You mean space elevator? Yeah. The current preferred method of getting into outer space is via violent, controlled explosion on rockets that convert rocket fuel into thrust. A single trip on the iconic space shuttle would typically burn 2 million kilograms of rocket fuel in a mere 130 seconds just so that it can achieve the 12 kilometers per second minimum speed required to escape the influence of the Earth's gravity. But once you get high enough, that's about 160 kilometers up, you're virtually halfway to anywhere else in the universe, according to author Robert Heinlein. And that's where the fun begins. Oh yes, sweet, sweet microgravity fun. The latest in space launch vehicles like the Atlas V core rocket booster is capable of generating upwards of 250,000 pounds of thrust. And although it has never been used to carry humans up into space, it is a step forward in the past 50 years that we've been sending things up into space. For a little less chaotic spaceflight experience, something with a little less kick, the Russian Soyuz is currently the preferred go-to vehicle for orbital spaceflight. And although it doesn't have as much legroom as the Starship Enterprise, or warp engines, the Soyuz can fit 3 cosmonauts, you and 2 of your friends, to boldly go all the way up to the International Space Station and back. I know it doesn't sound like much of an adventure, but we're working on it. One bright new horizon to look forward to is that we live in an age where the commercial sector is getting in on the action. Companies like SpaceX and Armadillo Aerospace, founded on a volunteer basis by legendary game programmer John Carmack, represent the frontier for normal people like you and me to get as close as we can to outer space. Armadillo Aerospace bases its business model on building vertical takeoff vehicles that are reusable in an attempt to phase out the age of the cumbersome rocket booster. As my homie, the OG Carl Sagan once put it, we live on the shores of a cosmic ocean. 21st century humans are now taking their first steps towards conquering what in the universal century is known as the Earth sphere, the part of our solar system that encompasses the Earth, the Moon, and all the Lagrange points. The spaceflight technology that we see today represent the beginning of our species to liberate ourselves and break free of the chains of gravity that hold us bonded to the Earth. Le number 3, Psychomus and Psychoframes. The iconic mobile suits of the Gundam series are driven by Psychomus, short for psychic communicators, that allow the pilot to control the machine through thought alone, reducing reaction time and human error. Many other sci-fi universes take advantage of mind-machine interfaces like Pacific Rim and pretty much every other mecha anime. Mind-machine interfaces are a homage to what futurists call the singularity, an event sometime in the future where human intelligence will merge with superior machine processing power and lots of freaky things will happen. Either for better or for worse. The human brain is one of the most complex structures to exist in the universe, perhaps even next to the universe itself. Nothing else that we have yet to discover so far attempts to understand itself like the human brain. The brain is made out of nerve cells that process information via electrical and chemical signals. Everything that humans have ever done, achieved, or thought of began with the firing of these signals across billions and billions of neurons within the human brain. Every act of kindness, declaration of war and peace, desire to love or hate began with this process. From the design of the Eiffel Tower to the notion that we could somehow expand into space and enrich the potential of humanity, it all started with high-speed electrochemical impulses somewhere in someone's brain. We've reached a stage today where we can fundamentally measure these signals and turn them into commands for external electrical devices. And that's the premise of the brain-computer interface, that we may bridge the gap in between mind and machine in an attempt to fix or enhance normal human capabilities. How it works is actually quite beautiful, really. There exists a potential difference across neurons whenever nerve cells in our brains transmit information via electric charge. It's almost like how electronic circuitry works, but not quite. Some of these signals end up escaping the insulating coating of the nerve cells called myelin, and we can actually use electrodes to pick up and interpret the meaning of these signals and drive electronic devices. Now it even works the other way around, where information is transferred into the brain via the electrode from an external source. We are on the brink of a new world out there. It's a great time to be alive. This technology will allow us to let blind people see again, disabled people walk again, and enhance human performance in everyday activities. Brain-computer interfaces truly bring to life the age-old phrase of mind over matter. And just like in the world of universal century, where technology empowers humans to greater and greater possibilities, the science of our own world today may allow us to empower less fortunate humans to possibilities undreamt of in any other time before.
There you go.
It's beeping.
So now technically your device is on. Can you tell? Oh, that's exciting! Here, you can put it down for a second. Just get used to the sound. What does it sound like? Can you hear me? Can you hear your voice? Is your voice a little loud?
No, not really.
Well, that's good.
My laughter sounds loud.
Yeah, you'll get used to all of that over time.
Numero dos, Minovsky physics and the compact Minovsky fusion reactor. Okay, this one's a bit of a stretch. To power the mobile suits seen within the Gundam series, the writers actually created their own extension to the laws of physics called Minovsky physics, centered around a mysterious superparticle called the Minovsky particle. In the Gundam fictional universe, Minovsky physics is discovered by a man named Dr. Trenov Minovsky, born in the Urals near Chernobyl. You have to give credit to the Japanese writers for paying tribute to the sweeping changes brought about by the atom in our world and reflecting it in the fiction of Universal Century. The story of Dr. Trenov Minovsky is obviously inspired by that of Albert Einstein and J. Robert Oppenheimer, whose work, although changed the course of history, had some regrets that their science led to the invention of world-ending weaponry like the atomic bomb. However, as a tragic twist to the Gundam story, Dr. Minovsky was later killed by one of his own inventions. Minovsky physics postulates that helium-3 fusion reactions produce trace amounts of an elementary particle called the Minovsky particle. In Gundam, Minovsky physics eventually led to the development of the compact Minovsky fusion reactor, a small fusion reactor with a crazy high output that could supply the mobile suit with all of its fighting capabilities. Unlike its real-life counterpart that uses muons, the compact Minovsky fusion reactor uses Minovsky particles to catalyze a fusion reaction so that it could happen at much lower temperatures. The special characteristics of the Minovsky particles are also put to use in spacecraft propulsion and combat communication. I get it, it's a plot trope, something to make the story interesting and a little bit more believable. But in reality, superparticles represent the cutting edge of particle physics research. An elementary particle, like the hypothetical Minovsky particle, would have to represent one of the basic building blocks of everything that we see around us. Now we know that atoms are made out of protons, neutrons, and electrons, but what are they made out of? If you break them apart, you find even smaller pieces with even stranger names like strange quark and W boson. On a fundamental level, you and I are both made out of quarks. For every proton in your body, there is one up quark and two down quarks. I'm not kidding, they are scientifically acknowledged as quarks. Hey Ed, what did Donald Duck say when he got his PhD in quantum physics? Nothing, he just quarked. Get it? Quark. Because he's a duck, and ducks quack. Anybody? No? Never mind. I thought it was funny. We can actually prove the existence of these particles in particle colliders that play a crucial role in expanding our understanding of the basic building blocks of all of creation.
We just take little bits of matter, little bits of this stuff, and accelerate them to as close to the speed of light as we can get, and then smash them together right in the middle of that detector to recreate the conditions that were present back at the beginning of time.
Particle accelerators like the Large Hadron Collider also function to bridge the gap in between the practical and the theoretical. You may not see it today, but these massive facilities that break apart tiny pieces of matter into even tinier pieces of matter can contribute to lots of spin-off technologies like neutron therapy, cancer treatment, and superconducting wires. If anything can be likened to that of a modern-day Temple of Babylon, where the dreams of the human mind come to be realized into greatness, then particle accelerators are like the building blocks of which a future of infinite possibilities can be built on. As the story goes, the Minovsky particle was discovered on a dare by Dr. Minovsky, whose research initially appeared to have very little practical value. Beyond tributing the destructive potential of cutting-edge technology like the atomic bomb and the mobile suit, the writers of Gundam also told the story of human curiosity and one man's desire to simply understand more about the world we live in. It's a story that lives on in all of us, in humans everywhere that have wondered about the nature of stuff and where all that stuff came from. Ichi, space colonies and space habitation. Space colonization is a major theme in universal century fiction, with the conflict between Earth-based Federation and space-based Zeon starting because of an increasing divide between humans from Earth and humans from space. The writers of the Gundam series took their story one step further by modeling the habitat of the space colonists by actual designs proposed by American physicist Gerard O'Neill in his 1977 book, The High Frontier. 1977! 1977! Given that the original Mobile Suit Gundam was released in 1979, the writers must have been very well versed in their reading of actual science fact when they started to pen down the original Gundam universe. Or it could have just been a giant conspiracy theory. Visions of the future, my friend. Visions of the future. In the 1970s, Gerard O'Neill and his students at Princeton University conducted a study that would eventually lead to the design of the iconic cylindrical-shaped O'Neill Space Colony and Laplace Station, calculating the basic human needs for survival in outer space, like energy, air, water, and terrestrial gravity. The study was very thorough for its time and involved quantitative analysis for the design of a 30-kilometer-long solar-powered rotating cylinder that could house 1 million immigrant spaceflights. The stations would be strategically placed around the 5 Lagrange points in outer space, which are 5 points of gravitational equilibrium around the Earth, Moon, and Sun system where objects can be placed without drifting away on crazy orbits. Elementary space engineering, my dear Watson. Tally-ho! Gerard O'Neill, like Konstantin Tsiolkovsky before him, believed that humans must make the move towards living and thriving in outer space to allow for the environment of Earth to recover. Space colonization also comes with the opportunity of building our own utopian society, free from the scars of discrimination and hatred that have weighed us down so much here on Earth. But to quote French astrophysicist Nikos Prantzos, it may be that we are able to prove ourselves the masters of living and working in outer space, but yet we are still unable to prove ourselves the masters of the many aspects of our own human nature. Okay, I'm back. Time for a reality check. The International Space Station, or ISS, is currently the largest operational space habitat and represents an effort by the many nations of Earth to unite in a non-militaristic venture into outer space. Recently, the Chinese space station Tiangong is currently the only contender to the ISS, and while not being as large as the International Space Station, reflects the exploratory nature of human beings regardless of their nationality or race. The record for the longest anyone has lived in a space habitat belongs to a cosmonaut Sergei Krikalev, who spent a total of 803 days, that's more than 2 years, alternating in between ISS, Mir, Space Shuttle, and Soyuz environments. Those Russians sure have tough spacer balls. In Soviet Russia, space explores you. Now you don't have to be a burly Russian and drink vodka straight out of the bottle to make the trip 370 kilometers up to the International Space Station. Heck, nowadays even Malaysians can do it. But living in space is obviously not for everyone. For a species like human beings that evolved here on Earth, zero-gravity environments are pretty much alien to us and put a multitude of different stresses on our bodies and our minds. Prolonged exposure to zero-gravity environments results in a loss of muscle mass. Ever since there has ever been humans, we've lived under the influence of Earth's gravity. Our bodies have muscles that counteract against terrestrial gravity every time we move around. It's something that we don't tend to notice, but it's there. In a weightless environment, when these same muscles have no need to counteract against gravity, they end up weakening and deteriorating. Basically, you lose it if you don't use it. The only way to prevent this is to exercise intensively. NASA astronauts exercise more than 2.5 hours a day just to maintain muscle mass. Just to maintain, we're not talking about gaining here. Space is not a place for bodybuilding. You want to touch my biceps? On top of muscle atrophy, cosmonauts must also deal with high levels of radiation, motion sickness, and fluid redistribution throughout the entire body. Not fun. Now, one way or another, we've all glimpsed pictures of Earth from space through either stills or videos on the internet. But what is it really like to be up there? Astronauts have described a mixture of different emotions when floating out in the blackness of space. From insane levels of oneness, interconnectedness, and peace with the entire universe, to even loneliness, anxiety, and depression. But regardless of the challenges, a great deal of the human future is no doubt set to take place in the great depths of outer space. And that's it, ladies and gentlemen, earthbound humans and spacenoids alike, we are done. We've only just scratched the surface of the many amazing technologies from the Gundam universe. There's still full 3D panoramic cockpits, AMBAC systems, Gundanium armor, and Veda supercomputers, to name but a few. But what I want to end with is, as was repeated so many times in the final episode of Gundam Unicorn, that is, it is a world of possibilities. But beyond just embracing the world of technological possibilities, it is even more important that we embrace the world of human possibility found within us all. My name is Son of Terra 92, and this has been another Science Epic video log. Thanks for watching, folks. Make sure to rate, comment, and subscribe. It really keeps the channel going. Expect more from me, and I will see you guys in the next video.